Okay, I think we'll go ahead and officially kick this webinar off. All right, hello and welcome everyone to today's webinar, The Intelligent Mine, part of our Mining Innovation Across the Life Cycle webinar series. The webinar we're going to be kicking off this webinar officially. So again, welcome to everyone. My name is Tammy Pisani, the Offline Membership Manager, and I will be your host today. Before we begin, on behalf of Osmine and all of our presenting companies, I would like to acknowledge that I am hosting this webinar from the traditional lands of the Yagara and Turrbal people, and we acknowledge the traditional custodians of the various lands on which we are all meeting today and recognize the Aboriginal and Torres Strait Islander people attending this webinar. The point of this webinar today is to showcase some of offline member technology. And as the mining sector is undergoing a significant transformation driven by automation, digital systems, AI, sustainability, this six-part webinar series is really driving the critical points across the mining lifecycle. This session will highlight how intelligent technologies are driving greater efficiencies in fleet management, processing, logistics, decision-making, remote operations, and really unlocking new levels of productivity and safety. The format of today's webinar consists of presentations by each of our six member companies, and then we'll follow that up with a live Q&A session with all of the presenters. So if you have questions during the webinar, you can submit them at any time using the Q&A interface. And again, we will present those questions at the end once all the presenters have finished. And I should also note that this webinar is being recorded. All right, today joining us, we have six representatives from leading offline member companies who will share their latest innovations, insights, and real-world applications. Today's presenters are Mathew Cook, Product Manager for Fiber Optic Sensing with Hawk Measurement Systems, Peter McPherson, Director of Engineering with MRA Automation, Garry France, Product Manager for MoistScan with Real-Time Instruments, Dr. Joe Cronin, who is the CEO of Australian Droid and Robot, Dominic Stoll, Solutions Manager with MyPack, and last but not least, Albus Duran, Senior Consultant with Aviva. All right, well, that concludes the welcome and introduction. So without further ado, I would like to hand it over to our first presenter, Mathew Cook. Matt, over to you.
Hi, everybody. My name's Matt, and I'm from Hawk Measurement Systems. I'm presenting the Praetorian Conveyor Health Monitoring System, which is a fiber optic based technology that's able to detect faults in conveyor belts across huge distances. So Hawk Measurement Systems has been around since 1988, so it's been around a little while. We're full stack in terms of development, production, sales of all of our instrumentation. A lot of our traditional instrumentation is for level applications, block shoot, that kind of thing. But the fiber optic product is a somewhat unique product within our offering, as it lets us really do big linear asset detection. So whether that's pipeline leak detection, perimeter intrusion detection, and in this case, conveyor health idler monitoring. So I've been with Hawk for just under 12 years now. I've had a variety of roles, but I've been in this role for about 8 years, and I'm based in the Melbourne head office. So the application problem. Why do we monitor conveyors? Well, because if you leave them to their own ability, they are going to break. They have a huge number of moving components, and this is really going to tend to form a lot of your uncontrolled downtime within a mine site. So idlers themselves can represent something like 25% of all stoppages of conveyor belts, especially those that are considered uncontrolled downtime, so non-planned downtime. So I double clicked there. So the application as a kind of configuration, as you can see, an idler like this in the background where it's kind of torn in half. The idea here is that we are presenting idlers with a traffic light condition to you, idler by idler, frame by frame, on a live graphical user output. We provide that to you every single day. And in the case of critical idlers, we provide that to you with a 1 minute update rate. And all that's required in the field itself is a fiber optic cable in a casing solution. There's nothing else required in the fields. It's literally just the cable, and it's attached to the stringer. So this is what it looks like in field. You have either an aluminium or a stainless steel casing that holds the fiber optic to the structure. And then in the control room, typically you're in your MCC or in your high voltage switching room, you'll have some rack space, or we can provide a rack. And then you put the devices in there. They connect to these fibers, and the vibrations come through the structure to the stringer and then move into the fiber itself. Those vibrations are different when those idlers start to struggle and have issues. And we actually look at the frequency of those idlers as they start to fail. When they move through known failure mechanisms, we then report them as issues to your maintenance and inspection personnel. So it's relatively simple if you can get around the idea that the only thing doing the sensing is actually the fiber itself. So the way we install this is we put the casing on, we put clips in the fields, and that all kind of goes together. So that's the actual install. That's all you see in the field there are those casings. Again, pretty simple configuration. Now, generally it goes on the inside of this stringer structure here. Can go on the outside, just typically the inside is where it has the, a nice, free, easy path, and it's out of everyone's way. So the great news about these systems is with a single one of these, you're able to handle some pretty significant ranges. The range capability of the Praetorian in other applications is upwards of 40 kilometers. In conveyor monitoring, it's a little bit shorter. You're looking at around a 10-kilometer range per system. So even if you've got a substantial like iron ore processing facility, or if you're doing some big overland transfers, you can do substantial amounts of belt with one or two systems. If you can understand that the fiber optic transmits light as fiber optic does for communications, and that you get a little bit of backscatter on that return light, effectively what's happening is there's a little bit of diffraction because of that light that comes back. We can tell it's been refracted back, and changes in vibration can change some of the peaks of that light. We then also calculate how long it's taken for that light to return back to us. So we get what vibrations are occurring at what location all along the fiber. So if you think about it, it's effectively turning a fiber optic cable into a series of contact microphones. Those microphones are equivalent of roughly every 250 millimeters, and we run them over 10 kilometers. So we basically get an audio track back from the fiber along the entire length. So as an example, we did a case study of a 7,000 meter 3-belt network. We did the installation of 2021, 2022 during COVID restrictions, which was fairly interesting, with calibration handover basically happening in December of 2022, January 2023. The ongoing operations and supply support agreement is been ongoing since 2024, and this has been successfully operating since. You can get an idea of the kind of outputs that you get here. So we can show you, for instance, on a conveyor, you've got a new conveyor that gives you conveyor number, gives you the frame number, left-hand side, right-hand side, its current priority, the previous priority, the fault range, if the unit starts having any issues, be able to determine the exact position of the fault, and also the date added. So it gives you all the new detected faults, all the faults that get worse, all the priority 1 faults. They're the ones that are a direct threat to your belt, and then all the cleared faults. So the system doesn't require you to go in there and actually clear the faults as you go through. It will tell you that those faults are now clearing. So it's really useful once you swap an idler out to actually see that it's moving into a cleared condition. So initial results were done as part of some experiments in 2017. You can see here we've got an inverted V style return idler, which has collapsed, and you've got a bearing end separation. These are considered a pretty bad kind of failure because of the system's capability of actually using that piece of disc effectively that's left over to slice along the belt, and it can rip, as many meters as you want to put past it in a short period of time. So we had this compared to an inspector whose job was to effectively try and beat the system at its own game. And back in 2017, which is, a little while ago in terms of the amount of work we put in since, we were typically beating the human inspection by roughly 10 days. So we were alerting to these conditions 10 days before these are discovered. In other applications, you can see here again, it's another one of these style of idlers, 28 days before human inspection was able to be detected. Now, there are some kind of idlers that we typically call them infantile failures, where they occur generally fairly early in the lifespan, but can go pretty catastrophic pretty quickly. In this particular case here, this idler broke down within a 90-minute period. It's one of the reasons we went from a 15-minute interval rate to a 1-minute interval rate to get a much, much faster result on that ability to detect fast failing idlers. So you'd still even catch these today. I'd like to mention as well that the system is capable with different software packages of either using pipe leak monitoring. It can also be used in perimeter security and threat detection. It's also capable of strain and temperature monitoring in earth and dam structures or even boreholes. And we've even used it to detect the presence and absence of rolling stock and even elephants in India approaching rail areas. So yeah, in summary, the system's capable of handling substantial ranges. It only requires fiber optics in the field, and it provides live updates to the user. So it lets you do things that you weren't previously able to do with, point instrumentation. That's it from me.
Awesome. Thank you so much, Matt. I'm particularly interested in the elephant detection system. All right. So next up, I would like to welcome Peter McPherson, Director of Engineering with MR Automation. Peter, the audience is yours.
No worries. Thanks, Tammy. So firstly, a bit of introduction. So my name's Peter McPherson. I'm the Director of Engineering at MRA and AXO 33. And today we're going to go through a subset of our smart product range, which is talking about our stockyard solution, as well as all the way through to our train solution. So looking at that pit to port end-to-end material tracking and focusing on the quality parameters of the material from end to end. So just quickly, just a little bit about MRA. So we started in 1998, based out of Newcastle, and predominantly focusing on systems integration. So doing PLC SCADA work in bulk materials handling. So a lot of work at export ports, mines, and the like. Focusing on getting optimization out of existing assets as well as new greenfield projects as well. And you can see there we've got a large customer base for those key miners. And in 2015, we started investing heavily in R&D and started to look at how can we take the automation of mobile machinery, conveyors, and the like to the next level. What is some additional information we could provide to the control system to make better decisions and in turn increase optimization. That's where we invested heavily over the years to a stage where we've developed a separate division of our business called AXO 33, which we're going to talk through a little bit more about today. So the AXO 33 product suite is made up of series of products that focus on that materials handling chain. So looking at stockyards, where we can model, create a digital twin, and look at what is happening in the stockyard to then give better information to stackers and reclaimers to get whether that's demanning, whether that's optimizing, or whether it's just asset protection as well. And then we have different modules, different options that can be added to that as well. So start to look at what has happened for the past 30 days or what is happening the next 30 days. What is the stockyard going to look like? Then also through to grade and quality tracking as well. And that's what we're going to put our attention to today, looking at that grade throughout. And what you'll see there on the slide is the maturity of our stockyards product. We've processed over 2.3 billion tonnes with our stockyard solution. Onto the ships to look at ship loader collision avoidance. So taking a manually controlled machine and ensuring that you cannot collide. So on that asset protection item as similar to the stockyards, but then also being able to give a tool to the operator to be able to better perform in adverse situations as well. Then that can lead on to completely automating the ship loading process or grab unloading process. And once again, you can see the maturity there of our solution. Then on to trains, looking at the automation and optimization of unloading and loading of trains. And we'll speak briefly about that whole pit to port style process. So a little bit about our stockyard solution. So it's all about creating a digital twin of the stockyard. So using information from the control system, such as machine positions, being able to build a accurate volumetric model of what is happening in the yard, and then being able to make smart decisions on that, whether that's telling the machine where you can turn around or where you should start for a stacking task or where you should start for a reclaim task to make the most optimal decisions, or whether that's a machine stockpile's being manipulated by a dozer and it's an odd shape. So being able to determine where is the best location to resume reclaiming of that stockpile, or even just supporting operations with the knowledge of how much material is on the ground, what is the volume of material in a certain region. And then, as I mentioned previously, there's additional modules to look at of, okay, what will my stockyard look like in a day's time? Am I going to have a clash of trying to have a stacker and a reclaimer operating in the same zone at the same time, or am I going to run out of room? So it's all those different scenarios can be run through. This system is applicable to any type of bulk material. So we've deployed in coal, iron ore, bauxite, potash, and other heavy metals as well. So it's applicable to any type of bulk material. Can work with any type of machines. So you can see in this image here from Abbott Point Coal Terminal in Queensland, there's stacker reclaimers, but also works with just stackers and bucket wheel reclaimers, bridge reclaimers, A-frame scrapers, or as I mentioned previously, stockyards that are just dozer operated, pushing into feeders, for example. The system, and it's the same approach with all of our system, stockyards, trains, or ships, is we're not replacing the control system. We are essentially adding eyes to the control system to make better decisions, being able to utilize laser scanners on the machines to even get that model even more accurate to then make those better decisions. But it's keeping all the control aspects inside the PLC is a key part of all of our systems. And one of those additional modules is being able to do grade tracking. So being able to take the grade or quality from a sensor, whether that's an online analyzer or whether that's from a laboratory sampling, and being able to track that into the stockpile. So having that knowledge of where that material has fallen, not as an average across the whole stockpile, but we can actually model down to 0.1 of a cubic meter blocks inside the stockpile. And what you'll see in that video is we can then do an MRI scan throughout the pile of what the grade is throughout. So this one at the moment is ash content. So it's a coal stockyard looking at the ash content through the pile. And you can see those different bands throughout. So what the system can then provide is a accurate plan of, if I was to reclaim this stockpile, what will I actually achieve? So it's not based upon averages. It is actually adding up all of those little bricks and telling you exactly what grade you will achieve. And we can look at all of the different elements of the material. So if that's coal, we might be looking at ash content, calorific content. If it's iron ore, for example, you might be looking at iron content, sulfur. So we can provide a very accurate grade prediction of what you will achieve. But then you can also use it the other way if you're looking at blending into the stockpile, where should I put this material, or where should I reclaim from? So it's very powerful when you start to have analysis down to this level of what is happening in the stockpile. So all of our web tools can then do all those what-if scenarios to help support that even further. Just a quick couple of case studies to close it out. So one of our deployments is at Port Kembla Coal Terminal. So we automated this facility back in 2015 using our stockyard system and introduced the grade tracking in 2024. And you can see another screenshot of the system in action. And just a little bit of information there about the time that was saved by having this system. They previously were tracking grade through spreadsheets, multiple staff, so being able to automate that process and getting a higher predictability of what they're getting on the export. And to wrap things up is just on the end-to-end functionality. So being able to take that grade out of the stockyard and being able to track that all the way through to a train loadout, for example, of a mine site, or whether that's into a vessel for an export terminal. So being able to track that zero 0.1 cubic meter segments of material onto the conveyor streams through any chutes, bins, and into the train. You can see a bit of a graphic there that's showing the material in each wagon and what that looks like. I'll hand it back over to Tammy.
So thank you so much for that, Peter. Great presentation. I would like to remind the audience that you can submit your questions for today's presenters at any time during the presentation, and that we'll have a live Q&A at the end. All right, our next presenter is going to be Garry France, Product Manager of MoistScan with Real-Time Instruments. Garry, the audience is yours.
Thanks for that, Tammy. Look, my name is Garry France. I'm the product manager for MoistScan within Real-Time Instruments. What we're talking today is about the ability to control your moisture in your product. So we find with now everyone's leading towards an intelligent mine using real-time analysis. The use of the right tools to do the job is critical. So why moisture matters. So moisture is not just a metric. It's both a problem or a risk to operations, but it's also an opportunity for each operation. So the moisture content, whether it be coal or iron ore, or bauxite, etc., every stage it influences the mining, influences throughput, handling, energy use, product quality, and poor control can lead to things like material handleability problems, blockages, dust control, and penalties. So accurate real-time data enables consistent specification. It provides faster data-driven decisions, being information that's provided on a second-by-second basis, rather than traditional laboratories, which can take 24 hours to get a result from. So, as I said, real-time data enables real-time decisions. So decisions that are made also on a second-by-second basis, rather than traditional sampling and laboratory practices. So it's fundamental for automation, fundamental for process optimization. It provides continuous monitoring. It removes the delays that we normally waiting on lab turnaround time, and integrates directly with plant control systems for closed loop feedback. So supports all the modern protocols, Profibus and Profinet, etc. This is just a snapshot of the technology. It's a bulk material analyzer for bulk material flow. So it's non-contact, non-destructive. It's a microwave transmission technique. So it measures nearly 100% of the product. Accuracy levels we get are normally in the 0.3 to 0.5% range at one standard deviation. Provides continuous measurement, updated every second. And has proven performance like sites like FMG Solomon and others, where they have over 20 analyzers installed throughout their plant at the moment, train loadouts, processing, run of mine, ship loading, and so forth. One of the areas we've been strong is the loading ports. So the intelligent port, if you like. At this port in Queensland, we have 3 moisture analyzers on the train loadout, the train in loading. And then we have 3 MoistScans located on the ship loading. So it helps improve stockpile management, moisture consistency. Probably most importantly at this site is dust issues they have with the local community. Real-time data prevents TML exceedance. It's shown a 3 to 5% increase in the load-out efficiency through these live adjustments. Less lab samples are required, faster compliance and reporting. As I've said before, elimination of the long wait times for laboratory results. So the comprehensive coverage from multiple MoistScans and live data feed simplifies blending, stockpiling, and loading decisions. Another example is the iron ore industry. I think this one might be whaleback. So what we're doing here is eliminating high moisture events. So where the moisture exceeds over short terms, it results in spillages, blockages, and so forth. So it results in recovery of, shown to give results where recovery of 13 hours of production on a monthly basis. Save production time equates to several $1 million of revenue per month. And the integration of the MoistScan into operation allows operators to make proactive decisions there and then, adjusting their feed processes. Recently, we've just installed 5 MoistScan analyzers into the gold industry. This one's in New South Wales, Cadia, I think. And this was driven by really dust issues and safer operations underground and creating a better environment for employees. So MoistScan's integrated with the automatic sprayers to maintain ideal moisture in real time. And the sprayers were a big help too in calibrating the analyzers. We could turn off sprayers, see the MoistScan respond correctly, and use that for verifying the results and calibrating the analyzers. The reduced dust, spillage, and carryback has contributed to 20% fewer conveyor stoppages, improved underground safety with up to 30% lower airborne dust and more consistent visibility. An intelligent process of closed-loop control, where real-time moisture data drives automated decisions. So now we can turn the real-time data from the MoistScan into actionable intelligence. So across many commodities, the MoistScan sensors can link live moisture information directly to mine control platforms. We do this in a variety of different ways. We can provide information directly to those platforms, information to a cloud, even feedback to web browsers and onto your iPhone as well. The data connection enables predictive moisture management, automated feed adjustments, and smarter decisions. So moisture, we believe, moisture management becomes the first step towards a fully integrated data-driven mine, integrating continuous moisture analysis into the decision-making process, and now sites move beyond measurement, achieving self-optimizing processes, reducing energy time and real-time ESG tracking. Whoops, I've gone one too many. Sorry, Tammy, I finished a little early.
Thanks, Garry. That was great. The connected technology is amazing to hear about. Thank you for your presentation. Okay, next up, I would like to welcome Dr. Joe Cronin, CEO of Australian Droid and Robot. Joe, the floor is yours.
Thank you, Tammy. I'm Joe Cronin. I'm the CEO of Australian Droid and Robot. We specialise in remote data acquisition for the mining industry and other hazardous industries. Oops. I think it's universally accepted that mining in the future will be lower grade, it'll be deeper, larger footprint mines, and they'll be more complex. I think it's also universally accepted that the deeper we go, the less forgiving the geotechnical hazards are, and we'll see much more stress rises, outbursts, rock bursts, potentially inundation, and seismic events. Oops, sorry. The bad news is that we incidents and fatalities in mining decreased in 2015, but now they're on the way back up. And unless we do something very different, that trend is set to continue as things do get deeper and more hazardous. And we believe data capture in mining is stuck in the 50s. We have teams of highly paid professionals deployed globally, going underground every day to acquire standard geotechnical, geological survey, regulatory and production inspections. And often these highly paid professionals are on a fly-in, fly-out basis. So for every 24/7 capability, like a surveyor or a geotech, you need 4 people. And you're flying them in and out business class. And then you're exposing them to hazards once they get there. I think this has been recognised by the industry. The thing about mining is that we can't eliminate hazards and we can't substitute hazards. Traditionally, we use engineering controls to protect our people, but with remote data acquisition and robotics and automation, we have a new control that's called separation. And it's a very powerful control because if it breaks down, the person and the hazard aren't in the same area at the same time. This has been recognised across the industry and from the Global Mining Group with their zero entry mining, which doesn't mean no people in the mine, it means no people in hazardous areas. BHP, Rio, Anglo, Vale, South 32 have all recognised the benefits of getting people off site and have very active campaigns and investment in moving people to remote operations centres. That said, over the last 15 years, the majority of focus has been on production automation. In recent years, we've seen an investment increase in development automation and the overall investment in robotics automation and AI increasing. However, since about 2020, the investment in inspection and data acquisition automation remains unchanged. And in every mine, in every underground mine in the world, there are teams of people doing ore sampling, crack mapping, mineralogy mapping, excavation mapping, surveyors, visual inspections, ventilation, and the rest of it. In one particular mine, we identified 126 individual inspections. And there's a cost to this. The cost of the people with the necessary skills and expertise to acquire and analyse the data, but particularly now with automation and big barriers around the automated area, you have to stop production to allow people in. Now, we can argue that we'll just schedule that, but rarely does that work. And we often find mines shutting production to allow geological, geotechnical survey inspections, which we believe in an average mine is costing about $250,000 every couple of weeks. And again, the constant changing nature of the mining environment means that fixed sensors is just not a solution. Another problem we have is that 86% of executives believe it's going to get more and more difficult to retain staff, which is why we believe in a similar manner that a lot of these inspections can be conducted autonomously and from remote operation centres. Our solution is a very ruggedised mobile robot specifically designed for the mining industry. It lives on the level in a ruggedised docking station where it's charged and has its sensors cleaned. So there's no requirement for someone to drive down or go down a shaft to deploy the robot. They stay on the level, they can be deployed from anywhere with an internet connection to the mine. They can go out and get LiDAR, high-res visual data, ventilation, atmospheric data, straight up into the cloud, and then that data can then be downloaded to the various packages that mining engineers and geotechs and geologists use. So some of the applications we're currently involved in, obviously underground mine mapping, surveying, convergence monitoring. It's about being able to continuously monitor the entire excavation on a regular basis so that you have early warning of any deformation. Blast re-entry, we can hide the robot around the corner, fire the shot, send the robot in to have a look the result, and also to measure the atmosphere and give you an early indication of when it's safe for re-entry. Vent monitoring we've discussed. Comms recovery for LHDs. When the LHDs go too far into a draw point, they lose comms. Instead of shutting down automation and sending a human in to get it out, we can simply send the robot in to re-establish comms. And there's some massive ESG benefits. By not sending people into the underground environment, you are saving a lot of people from being exposed to critical risks. We recovered up to 2 hours of production a day, which is a huge saving. A couple of months pays for the system. We saved 27 tonnes per robot of CO2 in terms of transport costs and providing an atmosphere and getting people underground. And of course, by having more regular, more hygienic data, we're able to decrease the uncertainty in the decisions we make in the underground space. What separates ADR is we started the company a kilometre underground. We have a huge depth of experience in underground mining. We also have a huge depth of experience in robotics and systems integration. We are very experienced in making systems that people will use, because if it's not easy to use, it will sit in the corner and gather dust and won't offer any safety improvement. So any questions, please feel free to reach out. Thank you.
Wow, you're bang on time, Joe. Well done.
Always, Tammy, always.
Thank you so much for the excellent presentation. How far everyone's come in automating mines is really, truly incredible. All right, our next presenter, we'd like to welcome Dominic Stoll, Solutions Manager with MyPack. Dominic, the audience is yours.
Thanks very much, Tammy, and pleasure speaking with everyone today. More than 70% of digital transformations fail to deliver their intended result. Replace the digital transformation buzzword with technology implementation if you'd like. There are 6 episodes in AustMine's Mining Innovation Across the Lifecycle webinar series, and 6 technology companies, including MyPack, sharing their great solutions with you in today's episode. You might be impressed by one or more of the technologies and decide to purchase. But how do you get that technology to stick and not collect dust like the previous presenter suggested? It's time to stop thinking technology implementation is just about the technology. My name's Dominic Stoll, and I'm the Solutions Manager at MyPack. Like any good consultant, I'm going to start with a qualifier. I'm not going to suggest that I'm an expert in digital transformation. I've experienced my fair share of technology failures, both as an operator and as a consultant, including at MyPack. But I do know enough to be dangerous. I'm going to share what I've learned throughout my career and snippets of what I've come across in my MBA, in conversations with practitioners, and research from thought leaders. What I'm going to cover only scratches the surface of successful technology adoption in mining, but hopefully it helps you become dangerous like me. MyPack is an industrial automation control and data engineering company specialising in the minerals processing sector. We've been around for almost 30 years, employing approximately 170 staff across Brisbane, Perth and Tucson. We pride ourselves on being technology agnostic and strive to be the trusted advisor to our clients. Today, I'll share an extract from MyPack's latest digital transformation guide. We created the guide because technology development's accelerating and 70% of all technology implementations fail. We know our clients want to transform, but are overwhelmed by tech, vendors, and buzzwords. Quite frankly, we felt our clients deserve better. As a tech company ourselves, we know the problem isn't the tech, or at least very rarely. It's about strategy, stakeholder engagement, trust, measures of success, and culture. We've built something to help project sponsors and champions, GMs, operations managers, and superintendents cut through the noise. Doesn't matter if you're starting your digital transformation journey or trying to reach the next level, the concepts hold true. The guide that we developed tries to simplify technology adoption down to 5 steps. Of course, there's going to be more, but I've only got 8 minutes with you today anyway. The 5 steps we selected are define the case for change, identify the bottleneck, engage stakeholders, implement and iterate, and then sustain the gains. We're often contacted by our clients saying that they need advanced process control or they need artificial intelligence and wondering if we can help. We keep having the same conversations over and over, and the conclusion's always the same. They don't need APC, they need to make money. APC may or may not enable that. There's absolutely no point in implementing APC if the plant doesn't have the necessary instrumentation and control elements for the APC to assess the situation and adjust the outcomes. Again, there's absolutely no point in implementing APC if the operations are running the plant in manual. The enabling infrastructure is needed before APC can be considered. Same goes for AI. AI might have made its way to the strategic plan. Why? Is it because the CEOs think that machine learning will come in and solve all their problems without them needing to change a thing, including how they lead, including the environment they create to enable effective decision making, including putting the systems in place to ensure discipline? Maybe. But if it sounds too good to be true, it probably is. Rather than starting with a solution in mind, the first step is understanding the problem. Einstein's recognized for the quote, "If I had 60 minutes to save the world, I'd spend 55 minutes understanding the problem." The case for change might be insufficient profit requiring greater efficiency. It might be hazardous processes requiring automation to separate humans from the danger. Whatever the case, defining the need for change is the first step. Sometimes our clients think they need to invest in modernising their entire plan all at once. You don't. You only need to modernise slices of the horizontal systems that span the bottleneck. For example, increasing the number of tags in your historian rather than implementing a high availability architecture. However, the real secret is starting at the bottleneck. The principle of theory of constraints is that value is only created when the bottleneck is unlocked and all resources are delegated to the bottleneck. There's absolutely no point in increasing grinding throughput if your tailings thickener keeps bogging and taking the plant down. Instead, start with a thin slice investment at the bottleneck. Do you have the critical instrumentation installed? Is it installed, calibrated, and scaled correctly? Is the control strategy correct? Is it tuned? Once you've unlocked the first bottleneck, where is the next? Go there. Is another thin horizontal slice required? Do you need to upgrade the HMI? Do that first before repeating the next vertical slice. Once you've optimized a few unit operations, you'll need to start considering the interactions between unit operations. Maybe then a model predictive control would be useful. What you're doing is investing a bit of a capital to generate a return. That return is either distributed to your stakeholders, reinvested in that unit operation, or you move to the next bottleneck and invest it there. Success requires a greater focus on technology adoption and a lesser focus on the impact from technology. And people are at the heart of technology adoption. So how can you work through that? Some tips. Describe the why. Connect the problem to the project's connect the project to the company's purpose and objectives. Explain how an individual's contribution delivers the goals. Establish what's in it for me. Leverage change agents by forming a cross-functional team of early adopters and empower them to succeed. Find the site influencers, the senior operators, the operational coordinators, the challenging supervisors, and encourage constructive contribution. You'll get a lot more buy-in if people's concerns are considered in the design. Coding someone's ideas into the solution creates a lot of goodwill. Communicate frequently and create feedback loops. Define measures of success and celebrate wins. Provide mechanisms for people to escalate concerns for when things don't go right. Ensuring people feel seen, heard, and supported is fundamental. Provide training and support to sustain success. You've now identified the problem to solve, your objectives and desired outcomes. a clear link to productivity and cost benefits, and a change team. It's now time to develop a roadmap that considers your ambition, budget, and timeline. An example roadmap for one of our recent clients is shown on the page. Probably a bit small for you to read, but it's sandwiched instrument and control with data and business intelligence around a capability, develop, and support. This roadmap applied our automation pyramid as a solution, but each technology implementation will be unique. All of this effort is wasted if the solution deteriorates after the project is complete and the project team disbands. The previous steps are all about creating early value that leads to early success that builds credibility. The credibility creates buy-in, and you start to develop a continuous improvement culture that gradually turns into an innovation culture. And you've started a flywheel that continues to generate value. The ability for the systems to survive in crisis or when a new leader comes in with different management paradigm is now established. Thank you very much. Feel free to get in touch if you'd like to down the track.
Awesome. Thank you so much, Dominic, for sharing that practical application of a roadmap for success. That was excellent. All right, before I introduce the final presenter, I would like to remind everyone once again to submit your questions using the Q&A interface at the bottom of your screen. All right, our final presenter today is Albus Durand, Senior Consultant with Aviva. Albus, the floor is yours.
Thank you, Tammy. Hello, everyone. I'm Albus Duran. I'm a senior consultant working with Aviva. I've been in the mining industry for over 20 years implementing technology solutions for many mining companies, so I'm happy to be here today. I think it's very clear from what we've been hearing today that sensors, data, and automation are critical when we think about intelligent mines. And we know that there is a lot of data already available in many systems. But at the same time, we hear many people saying that it's very hard to understand and make the most of all the data that they know they have. So why is that happening? When we think about how data gets created across the life of any mine, we'll identify that there are many different teams that are very specialized. They are responsible for different portions of the data, and they use different systems and applications to manage it. That is great, but when you want to start sharing this data to other teams that could also benefit from it, that's where the problems begin. Because many of these systems haven't been designed with this level of interconnection in mind. They, in many cases, end up becoming data silos, which is a concern when we are trying to build an intelligent mine. This is why Aviva created Connect. Connect is a platform based on open standards. And what I mean with that is that we can collect data from many different types of systems, even directly from assets. And once we collect the data, we have many services that we can use to manage the data. We can add context into the data, create analytics, dashboards, even build applications on top of Connect. So in essence, what we're doing is bringing data from these disparate solutions into a central place where we can properly manage it and then deliver it to the people who need it. And let me show you how it actually looks in practice. So in Connect, when you are building models, for example, from all these different types of data, what you are effectively doing is building a digital twin. So when you are looking at a piece of equipment in Connect, you see everything that you need to understand what's going on. You don't have to think about all the different sources that originated the data and produced the data in the first place. Everything is in front of you for your understanding. We have many customers that are using this, and let me share one use case with you. This company has 6 or 7 different mine sites in different locations, and it's very common in the mining industry. These sites have chosen their own software that they want to use. That is great. They choose what is best for themselves. But for the central teams, this is a challenge because there's too many systems to manage. If they want to see the full, complete, holistic view of all the assets, that is very hard. this is why they selected Connect to solve this problem. And let me jump ahead and show you the end result. So today, they have been moving data from all these 6, 7 sites into a central platform where they can see all that information in a consistent way in real time. So they can see all the properties, the KPIs of these assets. And most importantly, I think they have been sharing this not only with their internal teams, but they have selected specific partners that bring additional expertise that they don't have in-house. So this collaboration between internal teams and external partners have allowed them to explore additional use cases that are benefiting the sites. So they, as I listed here, that they are reporting, that they are improving asset performance, starting to working to reducing the energy consumption, lower their cost, and start moving away from a schedule into condition-based maintenance. So I think this is what Aviva can allow you to do today, like bringing data from all these silos into a central place and enable this collaboration between different parts. But I wanted to show you as well what we are working as our next step, how to bring this forward with new tools and technology. And that's what I wanted to talk to you about, our industrial AI assistant, which we are building within the Connect platform to extend this even further, how to use the data. And let me actually show you how this works. Imagine that you are on a site and you need to troubleshoot an issue. So instead of looking for a dashboard, looking for a report, as you would normally do today, you just ask a question. Like, is there any alert related to this particular asset I should be aware of? And if the alert exists in the system, well, Connect will find it for you, it will present it, and you will know that it's there. Now, I might ask for specific data streams that are related to the asset I'm investigating. Again, I put that question to the chat. It will give me the answer, but what I want to highlight here is that there's a link at the bottom, because every answer that you get in Connect comes only from your data and nothing else. So you can be sure that you always get an accurate response, and you can confirm that with these links. Now, if while I'm troubleshooting this issue, I might think that bringing a piece of document could help me. Well, I can ask another question for a document. It will bring the document. I will have it in front of me. Now, I can start reading it, but if I'm new to the site, maybe I'm not familiar with everything, I might ask another question if I want to know about maybe what's causing this issue, and what could I do about it, instead of having to spend time reading the whole document at this time. Now, I have the answer in front of me, and I can start thinking about actually solving the problem. So I ask one more question about the inspection procedure for this type of asset. And if the information is available within my documentation, it will find it, it will present it to me again, so I can read it straight away. Now, I want to gain probably a little bit more understanding of what is going on. So I'll see if I can find a 3D model of the asset I'm investigating. So if the model exists within the Connect platform, it will find it, showing me the link, click on it. I'll be able to see the asset, and in this particular case, within the context of the whole plan. So I have a better understanding of what's happening with my asset, with my equipment, and I can start turning this conversation into an action. So I can request for a work order, which I can review, I can edit it, and when I think it's ready, I can send it to the maintenance team so they can go investigate and fix the problem. So I think what I wanted you to take from this is how we are changing the way and making it easier for you to interact with all these different types of data that might have come from 3, 4 different systems into a single consistent experience within Connect. So let me finish by sharing this idea with you. Operational data is a unique resource. The more people use it, the more valuable it becomes. I think it's critical for what we've been hearing today. So data, I think, is foundational for an intelligent mind, but we must treat it as the valuable resource it is. We need to curate it, manage it, so we can deliver it to the people who need it to make decisions. Thank you, Tommy.
Awesome. Thank you so much, Alva's fantastic presentation. And that actually concludes our formal presentations for today. So that leaves us about 5 minutes for Q&A with all of our presenters. So once again, I'll remind you that you can please submit your questions using the Q&A interface. And I'll invite all of our speakers to turn their cameras back on and join us. Looks like our first question is for Peter. And the question is, does your solution use radars, image analytics, or machine position only? And how does it help to optimize stockyards and stacking reclaiming operations?
Thanks, Tammy. That's a great question. So our system is very agnostic to sensors, so we can utilize any type of sensors located on the machine, whether they're existing or whether they're introduced. So we can work with no scanning technology, just using machine position from the PLC into our solution. And it's works quite accurately just in that volumetric model style approach. But then by adding on scanning technology, whether it's radars, whether that's LiDAR scanners, we can then increase the accuracy of the system. And obviously by increasing the accuracy of the digital twin means the automated decisions we're making can be of greater, are of higher confidence, so then we can get greater optimization out of the system.
Great, thank you. You're not off the hook yet. Peter, one more question for you. Regarding AXO 33 and other bulk material handling, does the system itself have a safety integrity level? Also, is there any data available to validate how accurate the digital twin is?
Also, yeah, very good question. We do have a module of our stockyard solution that is a safety system, so machine to machine anti-collision. We can achieve a SIL rating on that system, so making sure that the assets do not run into each other. For the other components of the system, it can be also used as a layer of protection to support functional safety systems. The second part of that question about validating the accuracy, we've had our system, both our underlying volumetric model, not using scanners, drone surveyed to provide the accuracy, as well as our scan solution. So we're around that 95+% accurate with just our non-scanner related system, so just our volumetric system. So typically within 300 to 400 millimeters for a stockpile. Then when we're adding in our scanners, so if you go for industrial 3D LiDAR scanners, for example, you can get to accuracy within 20, 30 millimeters. So from an overall stockpile point of view, you're around that 99% accuracy level.
Fantastic. All right, Albus, I have one for you. Does Aviva solution require integration with other systems like ERP, AMP to generate work orders? Are miners ready to expose other systems to Aviva chatbot?
That's a great question. Thanks, Tammy. Yes, there is. So I did mention that Connect, our solution, it's based on open standards. So we have integrations, open integrations, APIs we can use to connect Aviva with other solutions like ERP, APMs, and others. We do have some integrations that are already pre-built with certain solutions that we have, for example, integration with Databricks, with Microsoft, but we can create new ones as well, depending on the use cases that are required. Thanks.
Right. Thank you very much. Well, it looks like that is all the time that we have today. So I would very much like to thank all of our presenters today for sharing your technologies with us and your expertise. And thank you to all that took the time to attend today's webinar. I look forward to welcoming you to another offline webinar in the future. In fact, the next webinar in this series will be Monday, February 9th. And it will be the smart processing. So you can jump on to offline.com.au to register for that event and any of the other webinars remaining in this series. All right. Thank you again to our presenters and our attendees. And I look forward to hosting you again in the future. Go out and enjoy the rest of your day.